Fogg. I am with Dr. Ismail class, ELEN 464, Mechatronics. And today we're going to be here presenting Project 2. Project 4, my apologies. I will be exploring how to determine the joint angles needed for a robotic manipulator in effector to reach the specific X, Y, and Z coordinates. Using graphical methods we calculated that require joint variables with two different in effectors positions. Then we'll verify the results using simulation software and demonstrate in the link tutorial this particle approach that helps to visualize to see how joints influence the manipulator. Overall position in 3D to make it easier to understand the robotic movement and that is used to the control. Here is the first line of code that we have. First, we label line 1 as project H, second line math H, and of course the minimum and the maximum, which are as convert the angles and degrees to a PVM signal value to controlling servo. Uses linear mapping between minimum and maximum angles values to corresponding PWM compare values and calculated compare, which you see around here, the PWM value be sent based on the angle. Next, we're going to talk about the initial theta and theta 2, which would be, what are we talking about? Main, which is currently right here with the positions of X and Y represent desired in effector coordinates and centimeters, and A2, which denote link lengths for the manipulator arm. Here it is for R1, which is some of the calculations we did over here. I calculate the straight line distance to the end, effective position square equals x times x plus y. For another line for pH, phi 1, phi 2, and phi 3 are intermittent angles derived from the geometry of the arm using trigonometry for inverse connectors. And for T1 and T2 are the main joint angles derived from the angle calculated angles to achieve the in effector position. This part of this, the PWM setup, which allows the PWM to the control servo motors. And that's it for the video. That needed was illustrated. Of course, here was had a little difficulties with the arms and the actual servo board. And we have, of course, the connectors of the ground, the decoder, breadboard, and of course the robotic arm that we have. A couple of issues that came along the way, so therefore we don't have the brief showing what's needed. We're gonna show it later on, the motor moving, once we get everything fully assembled working due to the issues we having with our board. So that's the end of the video, and you have a good day. Nigga think he's slick trying to text.
Total honesty between us. No secrets.
I 100% agree.
So here's the secret to start off. There is no guy with a thing.
I was beginning to wonder about him.
Now you.